Good morning. I am V. Prasannanjaneya Reddy, working as Assistant Professor in the Department of ECE, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. In this session, we are going to discuss about how the memory is assigned for various peripherals in the embedded systems. Particularly, we are going to discuss about the memory organization of the TM4C123GH6PM microcontroller. For this topic, you can refer either Introduction to Embedded System by Shibu KV textbook or TM4C123GH6PM data sheet. Okay. First ARM. ARM means Advanced Risk Machine. It is a processor architecture designed by the ARM holding company. This processor architecture is used in the microcontroller applications. One of the microcontroller is TM4C123GH6PM. It is a 32-bit RISC processor architecture. This 32-bit indicating the bus width of this processing element is 32 bits. At a time, it will process 32-bit information. So, we can interface the memory to this microcontroller up to 2 power 32 memory locations. Two power 32 means up to 4 gigabytes memory locations we can interface. So 4 gigabytes means the address is ranging from 8 zeros to 8 Fs. We can assign the addresses to these peripherals from 0 to 8 Fs. In this range, particular memory location is assigned for particular peripheral for doing its operations, either read operation or write operations. If you look at this TM4C123GH6PM microcontroller, we can consider some of the following peripherals. One is flash memory, another one is RAM, another one is input and output ports, and private peripherals means additional hardware circuits or additional hardware components. Coming to the flash memory, the size of the flash memory for TM4C123GH6PM microcontroller is 256 kilobytes. So here starting address is 4 zeros. 256 kilobytes means, if you look at 256 means 2 power 8, 8 plus 10, 18 bits required to assign this address. 18 bits means 4, 4, 16. So 0, 0, 4 Fs. This is binary, this is hexadecimal to 1, 1, 4 Fs. So 11 in hexadecimal 3. So the address range assigned for this 256 kilobytes flash memory is from 8 zeros to 3FF. Like this we can assign. In this range only we can do the flash memory operations, either read operation or write operation. Next, coming to the RAM, the size of this RAM is 32 kilobytes. 32 means 2 power 5. Kilo means 2 power 10. Total 15 bits required to assign this address. So the starting address is 20004 So 15 bits means minimum value 15 zeros, in the sense in hexadecimal 4 zeros, to maximum value 3 ones. 3 ones means 7 and F. So the range of memory location, the range of the memory location address assigned for this RAM is 20004 to 20007FF. Okay. Next, for private peripheral IO ports, the starting address is 4000 to 40s to 5Fs. 5Fs in the sense 4 5s. So each hexadecimal digit takes 4 binary bits. So 5 means 5 fours, 20 bits. 20 bits means 2 power 20 bytes. Means 2 power 20 means 1 megabyte. So we are assigning 1 megabyte memory size for storing the input data or output data and do the corresponding read and write operations. So 1 megabyte means 2 power 20 bytes. 2 power 20 means here 20 bits required. 20 bits means in hexadecimal point of view, 1 hexadecimal digit required 4 binary bits. So by 4 means 5 hexadecimal digits. So minimum values are 20 zeros, maximum values are 20 ones. 20 ones means 5 Fs. So the address assigned for IO ports in TM4C123 GH6PM microcontroller is 40004 to 400F4Fs. Okay. Next, additional hardware for doing the specified operations like analog to digital conversion or digital to analog conversion or timer to provide the timing reference or counting operations, counter, like various peripherals. For storing corresponding information, we require some memory location. For that, here they are assigning E000 to 40s to E004 Okay. Starting address is E000 40s. Ending address is E004 Like this, we are assigning the some memory range to the particular peripherals in the TM4C123 GH6PM. We are taking one more example, TM4C1294 series microcontroller. In this microcontroller, we are assigning 1 megabyte flash memory. So 1 megabyte means 2 power 20 bytes. So here 2 power 20 indicating 20 bits required to store that address. So 20 memory locations means minimum value is 20 zeros, maximum value is 20 ones. So 20 zeros means in hexadecimal point of view 5 zeros. 20 ones means in hexadecimal point of view 5 Fs. So starting address is 0, ending address is 5 Fs. So this range of memory locations are assigned to the flash memory in case of TM4C129 series microcontroller. Next, flash RAM. The RAM capacity in TM4C1294 is 256 kilobytes. So starting address is 20000 4 zeros. So 256 kilobytes means 256 in the sense 2 power 8, kilo means 2 power 10, total 8 bits, 18 bits required. So the range is 18 zeros minimum value, maximum value is 18 ones. 18 ones means, so 4 into 4, 16, that is 4 Fs, and then 1 means 3. So totally the address range for RAM in TM4C1294 is starting address 20000 4 zeros and ending address is 2003 4 Fs. Next, for I/O peripherals, either input devices and output devices, for storing corresponding information, here they are assigning 5 Fs, means 1 megabyte memory size, 1 MB size, for storing the input data and output data. The address range is starting address 4002 400F and 4 Fs. The capacity is 1 megabyte. Okay. Next, for internal peripherals, internal private peripheral bus, PPB means private peripheral bus. The starting address is E000 4 zeros and ending address is E004 1 triple F. Like this, based on the particular microcontroller and corresponding memory size, the address range varies. So coming to the particular peripheral in detail, first watchdog timer 0. If you look at the TM4C123 GH6PM microcontroller, it contains 2 watchdog timers. So watchdog timer 0, the address starting address is 4000 4 zeros to 4000 0 triple F. Triple F means 12 bits. 12 bits means 2 power 2, 2 power 10. Means 4 kilobytes memory capacity is assigned for watchdog timer 0. In the same manner, watchdog timer 1 address range is 4000 1000 to the 4000 1 triple F. Okay, like that 4 kilobytes we are assigning for watchdog timer 0 as well as watchdog timer 1. Next, it contains different types of I/O ports, among them particular ports. Port A, general purpose input and output, port A register APP bus, advanced peripheral bus. So the address range is 4000 to 4000 and ending address is 4000 4 triple F. For port B, they are assigning from 5000 onwards, 5000 to 5 triple F. For port C, it assigning 6000 to in the 4000 series, 6 triple F. Means for each port they are assigning 4 kilobytes memory space. Similarly, for port D, it is assigning from 7000 to 7 triple F. This is a specific address range for ports available in the TM4C123 GH6PM microcontroller. Next, it contains this microcontroller TM4C123 GH6PM microcontroller contains 4 SPI devices, means synchronous serial interface 0123 or serial peripheral interface 0123. For these peripherals, they are assigning 4000, 9000 to 9000F. Sorry, for 0, SPI 0, 8000 to 8000F in the 4000 series. SPI 1, 9000 to 9000F. SPI 2, next A, A000 to A000F. SPI 3, address range is B000 to B000F. Coming to this universal asynchronous serial and receiver and transmitter, it contains 8 UARTs. The address of memory locations assigned for this UART is in the 4000 series C000 to C000F in the 4000 series. For UART 1, D000 to the D000F. UART 2, 4000 series continuation plus 4 kilobytes plus 4 kilobytes like that. They are assigning plus 4 kilobytes. UART 3, F000 to the FFF. Again, UART 4, 4001 series 0 to FFF. UART 5, 1000 to 1FFF. UART 6, 2000 to 2FFF. UART 7, 3000 to 3FFF. Coming to the I2C bus integrated circuits, this microcontroller TM4C123 GH6PM microcontroller contains 4 I2C buses. Integrated circuits. It provides the communication among various ICs within the motherboard. Those are 0, 1, 2, 3. Okay. Here I2C 0, the address is ranging from 4002 series 4 zeros to FFF. All are 4 kilobytes memory capacities. I2C 1, 4002 series 1000 to 1FFF. I2C 2, 4000 to 2000 to 2FFF. I2C 3, 4002 to 3000, 3FFF. Okay. Next, coming to the GPIO E port E and port F. The address range is 4002 to 4000. 4002 series 4000 to the 4FFF. Port F 5000 to 5FFF plus 4 kilobytes, assigning 4 kilobytes. Next, it contains 2 pulse width modulator for capturing the motion information, either temperature and pressure in the sea. Corresponding registers, we are assigning the memory location for this modules is 4002 series 8000 to 8FFF. And another one is 9000 to 9FFF. Register 1, register 2. Next, it contains, we can use these timers as either concatenating two 16-bit as 32-bit register or two 32-bit registers as 64 timer register based on our requirement. We can use these registers as 16-bit timer or 32-bit timer or 64-bit timer. Based on that, we can concatenate, means adding these two registers and get the 64-bit or 32-bit information. Coming to these timers, so timer 0, the address range is 4003 series 0 to triple F. Timer 1, 1000 to 1 F. Timer 2, 2000 to 2 F. Timer 3, 4000 series, 3 series, 3000 to 3 F. Timer 4, 4003 series, 4000 to 4 F. Like this, we are adding plus 4 kilobytes to the previous memory location. Again, timer 5, that is 4003 series, 5000 to 5 F. Next, if you are using as the timers register 32-bit or 64-bit timer, at that time, the address range is 6000 to 6 F. Timer 1, 7000 to 7 F. Next, it contains analog to digital converters. Actually, 12-bit, 12-channel, 12-bit ADC converters. ADC 0, that address range is 4003 series, 8000 to 8 F. ADC 1, 9000 to 9 F. Next, it contains analog comparators for doing the comparison operations. For that, they are assigning some memory locations. That address range is 4003 series, C000 to C F. Again, it contains CAN node controller, CAN, control area networks. That address range is 4004 series, 0 to F. Next, it contains different I/O ports. Each port address is port A, 8000 to 8 F, 9000 to 9 F, port B, port C. All these are 4005 series. 4005 series, A000 to A F. Port D, B000 to B F. Port E, C000 to C F. Port F, D000 to F. Like this, we are assigning particular memory location to the particular peripheral in the TM4C123 GH6PM microcontroller. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.